See this icon up here. Icon means picture. Whenever I say icon, it means a little picture. This icon says graphical analysis. Now some of you may have it on the desktop like this. Some of you may have to look for it. It would be in this area here on that. If you don't find it in either place, raise your hand. There is a third place. It's a little more complicated. But for most of you, it's either going to be on the desktop like mine, or it's going to be here in this section here. And just double click that and open it just like that. So you see that. Hit OK on that. So I got to kind of come over here. First thing we need to do is change to put the right axes on. Now our first graph is going to be distance versus the average time. Now these are rate graphs. Remember what we said about rate graphs? Rate graphs, where does time go on the x or y axis? Rate graphs, time goes on the x. Anytime it's distance versus time, velocity versus time. Rate graphs are always the times there. Now this is not going to be true for the next graph we do next time with our lab, even though we're going to be dealing with time. In that case, we're going to be dealing with a proportion. This time we're dealing with the rates. So see where the blue X is. Everybody see the blue X? Double click on that blue X and you're going to get a thing that says column options. Column options, just like out there. Anybody not get that? You double click on the blue X. So here we are going to change that. We are going to write average, type in average time in that one where it says units. You put an S because we're measuring in seconds, so we don't have to put parentheses. It will do it itself. We hit OK. And notice on our data table here, it's changed. It's put something in here. Over down here on this bottom here, it says average time in seconds. And it's changed our title to average time. It's done that automatically. Now we need our x-axis. Our x-axis is in distance, so we go to the green Y, double click on that. We're going to write in distance, and we measured our distances in centimeters. Hit OK, and notice our y-axis has changed, and it goes up into the title. So anybody not see has not gotten to those 2 points? Shut itself down again. Well, try this one. Maybe it will cooperate. Okay. All right. Anybody else? You can play a little catch up. But just watch up here. Now, there are 2 ways to enter your data. Now, when you do this with lab, like next time, you're not all going to have your own computer. Your group has a computer. So we do this with a group. If you're any time, you can go check out another computer. That may work. But usually we do it as a group. Now, one of the ways to do it, if we look at this column, is notice you have little arrow keys on your keyboard somewhere. There's little arrow keys. And we use those. For this one, like one person reads them out, they can do 10, 20, 30, 40, 50. Notice every time we just hit that little arrow key. And then we would just put maybe our times in, 1.5, 2, 4, 4.5, 6.2, and so on. All right, so that's one way to do it. The other way is you start in the X column and say we put our X value, and then you hit the tab key, and it'll go over to the distance side, 60. Hit the tab key, so it just keeps bouncing back and forth like that. Do not worry about what's happening on the graph. Now notice the graph is changing in scales, which is nice. So right now, everybody input their data, their average time and their distance data on that. Is it cooperating? So everybody should be inputting your data. And remember, since your person next to you was in a different group, probably when they gather the data, their data is going to be different. You need to get notebooks. Were you not here last time?
No, I was here to sit down.
Great, okay. Then share your data with your classmates. You might want to sit with somebody who was here for the last week. Whoever's single, you can sit down. Yes, sir. That's for the next one. No. What are you thinking? Average time and distance, right? The velocity will be for the next graph. We need to make our graph. Now, first of all, notice how right now our data table is a dark blue border. The graph is a light blue border. Whatever is the dark blue is the active window. We want to make sure we're done with the data table, we want to go over here. So we just basically click on the graph. Notice our graph window is dark. It's like when we print it, we need to make sure that's the dark one, etc. Now, first of all, you probably notice the scale pretty much takes care of itself. As we input data, the scale will make it as big as possible. And usually we like that. There are a couple of labs that we do have to play with the scale on that. But generally, we don't have to do anything to the scale. If it's really being persnickety, sometimes you might have to hit auto scale, and it would basically give that. It usually does it on its own. But notice we do have these green lines. These are connecting lines. We do not like connecting lines. That is an improper plot. They're like connect the dots. We do not connect the dots. In fact, if you leave them on your graph, you will lose points. Okay, this would be an improper plot. To get rid of them, all you have to do, pick a spot not on the line, but anywhere in the graph. Just pick a blank spot, double click. You get this little box that says graph options. So everyone, double click on an empty space. Anybody not get this dialog box? You just anywhere on the graph that is not on the line, you can double click. If you click on the line, you get a different box. So notice there's a little thing that says connecting lines. You click the little box, the check mark goes away, and we hit OK. Those connecting lines go away, we just have the dots. That's all we want. So again, it's just double click on the back. This is basically the first thing you do. You don't even have to have data in there to get rid of it. Just get rid of them. All right, now we need to do our line. We want a best fit line. And you'll notice at the top, there are these 5 little gold buttons. The one we use is this one on the right. Looks like a little arch. It has f of x. And when you push it, you get this box that says automatic curve fitting. This matches. And you see some formulas of different kinds of lines. Some of them are probably familiar. Linear, mx plus b, a quadratic. C squared plus bx plus a. We have inverses. We have inverse square. The ones we tend to use the most. Line, quadratic, inverse, and inverse square. Usually these polynomials, things like that, if you start getting more like x cubed, x to the 4th, things like that, you've probably done something wrong. And you're probably going to have to address it in your errors. Because we really shouldn't get these high order polynomials. Alright? Generally we're dealing with curved lines and straight lines a lot of times. Which means a lot of times either linear or quadratic. These are the two that kind of go together, or inverse and inverse square. Again, those kind of go together as well. So what you're going to do is just try some lines. And so first we try linear, straight line. We click OK. So everybody click linear, click OK. And you should get this, or something similar to this. It puts a straight line on there. Now how do I tell what's the best line? Well, there's a number down here. Near where it says OK, says mean square error. And it has a number. What that number tells you is how well do the points fit that line. The smaller the number, the better it fits. In fact, it's 0, that means it's exact. Perfect. 0. You are looking for which line will give you the lowest number. So you think, yes, sir.
Why does my line go the other way?
Because that's how your data is plotted. A line is a line, but it's going to go from highest to lowest. I don't know. I'd have to look to see how you guys did yours. Now, okay, if you like, so first time you're probably not going to hit okay. Okay is when you got the one you like. So you know, okay, this is 6.83. So now I'm going to try a new fit, and it gets me back there. I'm going to try the quadratic. Okay. Now I look at that. Oh, that's a 6.07. That was a better fit. Slightly, but slightly better fit. But I want to check some more, so I go, okay, let's try a new fit. Maybe it's really an inverse. I get there, it's like, well, no, that ain't an inverse. 1,470, things like that. So I check a couple, and I discover, okay, the best one was the quadratic. Of all those, the best one was the quadratic. And then I would say, okay, keep the fit. And I go like that. Once you get there, you kind of want to move this dialog box. This little box that kind of tells you all the values. So you just kind of move it down, maybe down there somewhere. Like that. Just move it out of the way. Then we'd be ready to print, almost. But we're not quite there. So everybody, find your best fit line. Which line is it on that? And get back to this point, and we'll go to the next step. Well, degree means like x cubed, x to the fourth. In other words, that's what the degree of the polynomial means. Like a quadratic is a second degree polynomial. Then it was third degree would be x cubed plus x squared plus x plus something. The fourth would be x to the fourth plus x cubed, and so on. Just means the highest power on the x. Mr. Borey, is that a question or?
Oh, no.
You guys are all printing out to the same printer. Now your graphs all look kind of the same, so it's kind of hard to tell sometimes one person's graph or one group's graph to another. So one thing we're going to do, you need to put your group's name. Now usually you would put your group name on. So I'll go right now. Up here at the top where it says distance versus average time, double click on that. And notice I get a little box. See the size of this box? This is as much room as you get to type. That's as big as it gets. But what I want to do, if I was saying the Bohr group, I would write Bohr. When we do groups, you put your group name there. However, today you are going to put your name into that little box, and you press OK, and that way you know when it prints out that it is yours. Because when you do groups, you have to print out multiple copies. But like if you're the Bohr group and you have 3 people, it's not necessarily going to spit out 3 copies for your group. It might print out one for you, and one for the Galileo group, then one for the Kepler group, and then 2 more of yours, and one of theirs, and maybe somebody else's. So they're not always going to come out in order. Usually they do because you guys just don't do it. But if 2 of you happen to hit their print button at the same time, they might not all come out in order. This is why you have to put what group they are. Now this is very important. Next part, time to print. Time to print. Okay? So, one, you need to make sure this is dark blue. If you happen to be clicked on this one, guess what? You're going to print out your data table. You don't want that. You got a data table already. You wrote it in your lab. Make sure the graph is blue because this will make a whole big graph. We come over here to the printer icon. Picture of the printer. You push that. It should say, mine says brother thing. That's the printer that sits on my desk. Yours should say like HP, LaserJet, something or other. If it says something other than that, we need to deal with that and I'll come help you. But if you're everybody else. Now notice down here at the bottom for copies, when you have a group, you have 3 people in a group, you change that to 3 and that's how you get 3 copies. Because everybody in the group needs one. But right now it should be 1, so if you have LaserJet and you're all ready, you can press OK and it's going to go print out back there. Anybody have something that doesn't say HP LaserJet? So if yours says HP LaserJet at the top, you can print out right now. Just hit OK. It's going to go print out. Anybody have something other than HP LaserJet? Like PDF Creator or something like that, XWriter. Guys, just look at the names. By the way, the bottom sheets are all mine. John. And Jasmine. John. Grab out your storage on these. Someone grab it out so yours comes through. And do not do anything to the graph because we still have another graph to make. Yes, sir. Could be you need to redo your thing. I'm not going to let you, for some reason, you're in a write-only mode. It just gets messy. You just have to re-enter the data, or get a copy of. For this particular one, get a copy from your classmate who has it, whoever was in your group. Shut down, and we'll go back to the next one. You have to start over again. If it won't print, you just have to. If it won't print, sometimes it does that. I'm not sure why it does that, but every once in a while it'll decide to do that. Just get a copy from, ask someone who was in your group that did it to copy their graph for you for that. So just ask them right now to give you a copy before they do anything else. So have them make a copy for you of their graph because their graph should be the same as your graph on that. Now, this is the three tiles. So look up here. So let's help people to try something. Up here. This is the three title. If you look on your rubric, it says something about a basic title. That's that. That gets you the 3 out of 4. To get the 4 out of 4, we have to add information. You have to handwrite it in. You always have to handwrite it in. And basically you're saying, what is that for this one? Well, either you have a curved line or a straight line. A straight line means it's constant. A curved line would mean it's changing. Mine's curved, so I would write distance versus time showing a changing velocity. Alright, so I would add, this would be that more descriptive title. Basically, I'm telling whoever's looking at this graph, what piece of information should I get from this graph? Okay? What? You have to write on the piece of paper that you got. Remember, there is not enough room in here to write. This is a very short descriptive title. Sometimes they're very much longer. This is rather short. This one's a lot longer, so you have to put it in that way on that. So you should be doing that right now to put that more descriptive title. Just get in the habit of doing that before we go on to our second graph on that. The graph is the answer to the first problem. Your hypothesis, is it going to be a constant or changing? Now the answer depends on your graph. This is how you would write it. It should be changing. Technically, if you have that ball rolling down the ramp, you should get a changing velocity, because as you go higher and higher in the ramp, when it gets to the bottom, it's going faster and faster. So you have a changing velocity. Should, depending on what yours is. Hopefully you got a curved line. Now, we need to do the second graph. Velocity versus time. Now I have a question. Is the time axis changing? No. Which is nice. We don't have to do anything to that. We only have to change one column. So what we do is we go over here, see where it says distance. We would double click on that. Double click on distance, because we are now going to change the y for our second graph. So we would change that as, what would we call it in your class? What would we call that? Which final velocity? So I would say final, I call it something different in each class. Final velocity. And it's in centimeters per second. Okay, and notice my y-axis changed. The name of the y-axis. Nothing else changed. But I want to point out, notice here the title. Did it change? You're going to have to go back and change that by hand. Many times it does not change. Sometimes it does. Most of the time it doesn't. I'm not quite sure why. So you come up here and write and just change that to final velocity versus. So we hit OK, notice our title. Now you're going to input your data. Input the final velocity column on that.
What about at the bottom where it says average time?
That doesn't change.
Keep it that way?
Well, because we're plotting at velocity versus average time now. This is an acceleration graph. And notice what happened. Did the graph go? Did that previous line go away when I start putting in the new data? Did it go away? Yeah, it did. Now, if it happens that it doesn't go away, you need to hit that little square on the corner and it will go away. Now, once you input the new velocity data, go back to this, click on the graph, go back up here, and go through that same process again. Go back through that same process again that we did before. I'm putting two lines up. Don't let that bother you. I want to show you something on that. Alright, so all of you, do your lines, print out, and write in your... Alright, so, you guys want to open up Mozilla, and you're going to want to go to Yahoo. Now, if you have a Yahoo ID already, or an AT&T ID, in other words, if your family gets their email from AT&T, like you're at sbcglobal.net or att.net, or one of a number of things. Or if you have a Yahoo account, which would be yahoo.com, rocketmail, like ym.com, there's several of them. You can just log in. You can log in, and we can go from there. Otherwise, if you have, remember I asked you a while ago to get a Yahoo ID, you're going to have to go up here. It says signing in. You're going to have to go to sign up and follow the directions from there. But right now, if you do have an ID, just sign in at this point. Woodside Physics. And you should, hopefully you come to this point, you're going to see something that looks like Wilbur. You're going to see Wilbur there. But you guys are going to see in the corner, you're going to see something like join the group. And you want to click that. There's a dialog box. You're going to put your name and your period, and I will approve you on that. Those of you who do not have a Yahoo ID need to get your Yahoo ID, then type in that URL and do the same thing. And once I'll give you guys some time to do all that, then we'll go over some of the features, the things you're going to be looking for. Yes, sir? Okay. Now, I realize the Gate ID won't let you put any age lower than 18. I understand that. But it always finds it interesting when I go through, it's like 40? Yes, sir. If yours isn't working, once the person next to you is finished, have them let you use that one. What are you trying to do?
Go to the
groups. Because you forgot the .com part. Groups.yahoo.com. The place you're most concerned about up here is probably files. The files section. In the files section, you find lots of stuff that you need. Like those of you who need if you need a new parent letter or something like that, or all the stuff from the first day packet, they're all here. Safety contract, student contract, the policy if you want to see that, and things like that. There's also the lecture PDFs. Not only do I record that you get off YouTube, the recording, like what I'm doing now, you get that recording, you can find the actual, I print out, so you can get a PDF of what was on the board, of the slides. So that kind of goes along with it. During lab, and one of the reasons we have for lab is we come down here to the Logger Pro files. Logger Pro is the program we use to run our probeware that we use for lab. These are the little programs that run those probeware. This is how you get it into your computer. Because a lot of them aren't there. The things are there. So we get it off this site. You would double click that and it opens it up in your computer when everything's set up. Also, there's copies of the lab sheets, which you really don't need because we don't do things, but projects, other information. Generally, it's this part that you're going to do, that you're going to see in this. So it's this thing that you're going to do on that. All right, so files is really where you're going to look most of the time on that. Okay, so we need to take a little bit of notes. So we're just continuing where you left off from your conclusion. Last time, we have a couple of slides to go through before we finish today on that. Next time we do have lab. We are going to do labs. It's very similar to what you did in the project. More data gathering, but also we have a different problem. It shows I can gather data. I can use the same data to solve a number of different problems. It depends on what relationships I'm looking at. In our exercise today, we looked at rate information. We're looking at velocity, acceleration, rate. Next time we're going to be looking at a relationship. We're going to be looking at proportionality. Is it an inverse or a directly proportional relationship? Things like that. So last time we ended with talking about acceleration. Acceleration is that change in velocity. Change in velocity. Where velocity is a change in distance, acceleration is a change in velocity. How much your velocity is changing. And does acceleration tell you what your velocity is at any particular time? Tells you how it's changing. Because you can have, I have a question. Can you have, say, a positive velocity and zero acceleration? There we have a C word for that. Constant. By the way, we're going to learn also next time we do lecture that you can have zero velocity and still have a positive, a non-zero acceleration. That's possible too. So remember, they are not the same thing. They ain't the same thing. Okay, so we just grab acceleration. Ah, that one. So acceleration at change in velocity, but there's a type of acceleration that's very special. That's the acceleration of gravity. It's so special that we give it its own special symbol. We give it a lowercase g. Uppercase G is something else. Capital G is actually the universal gravitational constant. It's used for something else. So little g is gravity. It's the only thing it's used for, little g is used for, is for the acceleration of gravity. And because it is an acceleration, it's still a meter per second squared, meter per second per second. And this is the acceleration due to the force of gravity. It's what gravity puts onto other things. And if you have mass, you have acceleration of gravity. And that acceleration of gravity is going to be dependent on how much mass you have. So the Earth has an acceleration of gravity. The Moon has a different value for the acceleration of gravity because it's a different amount of mass. The Sun has its, the Jupiter has it, Mars has its. You all have your own acceleration of gravity because you have mass. So you actually produce gravity and you have your own acceleration, although it's very, very, very small. Because gravity, of the forces that put together the universe, gravity is by far the weakest of those forces on that. But for the Earth, the value for Earth is 9.81 meters per second squared. Sea level average. The average value at sea level, because it does vary a little bit as you go around the Earth depending on what's underneath you. Because one, the Earth is not a sphere. You guys know that? Yeah. It's not a sphere. It's an oblate spheroid. It's kind of like shaped like a pear. Kind of stick bulges in the middle, has a little pump at the top. So it's called an oblate spheroid. So it's not uniform. It's not uniform all the distance. And when we learn more about universal gravitation, we'll understand why that makes a difference. But know that it makes a difference. It also depends on what's underneath you. Different rock, different densities, different masses will affect it. So as you travel, and also how high you are. If you're in the mountains, it's a little less than at sea level and things like that. So this is an average. And when we're in lab, this is the value we use. But when we're just playing around, working on things, we are going to approximate it at 10. So a lot of times in lab, or not in lab. So in lab it's 9.81, but when we're doing things out of the book, when we're talking about things in class, when you're taking your test, we approximate it at 10, because 10 is easy to use. We like 10. We don't always like 9.81. So 10. But what does this mean? It means if I drop a ball, it falls for 1 second. Its velocity will now be up at 10 meters per second. That's what acceleration means. Every second, we're going to increase 10 meters per second. 2 seconds, I'm going to be at 20. After 3 seconds, it'll be 30, and 40, and 50, and so on. Yes, sir? Practice. Practice. So if I drop a ball, I drop the ball, it's going to keep falling on that. And we have a term for that. Anybody need more time on this slide? So we have our last slide. We have a term for that. It's called free fall. And free fall. So here, watch. This free fall. Boom. I drop it. This is also free fall. Adrian. That's free fall. That's free fall. All that's free fall because as soon as the ball leaves my hand, the only force acting upon it is gravity. Only motion due to gravity. And 2 issues we deal with. We only deal with changes in velocity and changes in the distance moved. Change in velocity we call acceleration. Change in the distance is called velocity. And all objects accelerate the same gravitationally in a vacuum. So if I drop the ball. Now, on Earth, do we live in a vacuum? Do we live in a vacuum? No. You have air. Now I drop the ball over a short distance. Is air going to matter? Not really. Long distance, yeah, it is. But what if I drop a feather? It's going to matter. You know, Scott Carpenter, astronaut on Apollo 12, took a falcon feather and a hammer to the moon. And the moon doesn't have any what?
Gravity.
It doesn't have air.
Sorry.
No, that's okay. That's actually perfect because, see, you get that answer a lot. Now, the moon has gravity because it's mass, but it doesn't have air. It doesn't have air. So, on Earth, if I take my falcon feather and my hammer and I drop them, what happens? Feather doesn't fall the same rate as the hammer. But on the moon, where there is no air, they fall at the same rate. Because if the lighter object falls slower than the heavier object, shouldn't the piece of paper become separated from the book? But by dropping and putting the piece of paper on top of the book, I take away air resistance. I have no air resistance on the paper. It falls as fast as the book. It's only because of air resistance that it doesn't fall as fast. You take away air resistance, all things fall at the same rate. All things fall at the same rate in a vacuum. Okay, so write your summaries. Remember, we actually done a lot today, so you have a lot for your summary today. We finished up your exercise. You should be talking about that. We learned about the graphing program. You should talk about that. We signed up for the Yahoo group. You should talk about that. We talked about acceleration of gravity. So you have a number of things in your summaries today. Also remember, some of you have not always been putting summaries onto your reading. There, Cornell notes. Every time we do Cornell notes, at the end of a Cornell note-taking session, you write a summary. Whether it's a video notes, whether it's lecture notes, whether it's reading notes, whatever kind of notes, at the end of that note-taking section, we make a summary. So everybody should be writing their summary. Once you have finished your summary, you may go get your bag on that, which means no one should be moving right now because everybody should be writing their summary.